Okay, on problem number 4, it says evaluates an infinite sum from 1 to infinity of that ratio. It's an exponential, 6 to the n. The bottom has two factors in it. The first factor is 3n minus 2n, and the second factor is 3n plus 1 minus 2n plus 1. All right? Now, it starts off saying that, okay, a student handed this in, and the teacher said it was incorrect. All right? So what your goal here is look at what the student did, like you were a teacher, by the way, and determine what the student did wrong. And certainly, I gotta say it's not a difficult problem, but I found this to take some thinking, by the way, and I understand why someone would do this over here. For example, when you were taught partial fractions, you were taught that for polynomial, all right? And what you did was you put the factors down, and then you said, oh, I don't know what this is, and you said A and B. Now, this is true if they're linear factors, by the way, all right? The problem is it's all exponential, right? They're not linear. Anyway, what the student does, multiplies the LCD, they get this over here. Then the student says, just like they did for polynomials, they most likely would choose an easy number for n. If they did, they get A as 1. And then they choose another easy number for n. They choose probably minus 1, and they would get B to be minus 1. And then so it splits up like this over here. This doesn't work, though. If you would actually do this, do this arithmetic over here, you would not get this over here. And that's critical, though. But again, anyway, it certainly stands to reason what you've seen with polynomial partial fractions, but it's not working out, by the way. The student did use this, and again, things are they're going along really nicely. And the reason for that is a telescoping series, and the partial sum is really easy to write down for that. And then they get an answer by taking n goes to infinity, that partial sum, and they get an answer of 1. But again, it may look correct. It certainly really stands to reason. Where the reasoning fails, though, is in the partial fraction decomposition of the problem, that this, exactly where the problem failed, all right, exactly where it failed, all right? Everything else that follows from that, if that were correct, would look great, all right, would really look great, all right? So I'm going to say it failed there. Now, what they want you to do is find a fundamental error. That's just been pointed out to you in the partial fractions. Their assumptions is, it's a partial fraction problem. It could be. The problem is, what are the partial fractions? And that might be tough to come up with. Your goal is to find the error. We just did that, and compute the correct sum. So what I want to do is go to the whiteboard. I'm going to write the problem down again. The problem, I have it written down. I got to find it again. It's the sum. Put this over here. N equals 1 to infinity, and it's 6 to the n. And on bottom, you get 3 to the n minus 2 to the n. And then you get 3 to the n plus 1 minus 2 to the n plus 1. And I'm going to say I don't know what that is. And if they're asking me to find a sum, there's a good chance there's a sum there. So the question is, what would you do over here? One thing I notice is the choice of numbers in the problem. I do see 6, I do see 3, I do see 2. So I'm going to say, I'm just going to look at the this thing over here and see if I can get that simplified a bit. All right? So I'm going to write that down. It's 6 to the n. And this is 3 to the n minus 2 to the n. It would be nice if it were a partial fraction, though, and I'm hoping that we get a telescoping series at some point. But I don't see it right now. So what I'm going to do is write down 6 to the n is actually 3 to the n times 2 to the n. All right? 3 to the n minus 2 to the n, 3 to the n plus 1 minus 2 to the n plus 1. And again, just massaging this with what I know from algebra. And I'm going to divide the top and bottom by these factors over here, and there's 2 of them. So if I divide the top by that factor, I would get 1. If I divide the bottom, I'm going to split into 2 separate factors. Let me write this down for you. So 3 to the n minus 2 to the n. I'll divide it by one of those factors, and this is 3 to the n plus 1 minus 2 to the n plus 1. Now, I'm not think the choice really matters too much over here, but I'm going to divide the, let's take a look at this one. I'm going to divide the first factor by 3 to the n. So I just use this one, and the second factor by 2 to the n. All right, let me see if I can write that down now. And again, someone says, why are you doing that? I'm seeing 3's and 2's in the problems. I'm going to try to reduce it. It's 1. What do you get up here? 1 minus. Then you get 2 to the n over 3 to the n, which is 2/3 to the nth power. Now let's do the other one. What are you going to get? A little more complicated. You're going to get 3 times 3 to the n over 2 to the n. Minus, you can get 2 times 2 to the n over 2 to the n. All right, I'm going to keep working on that. What do you get there? Whoops, I'm too far there. Still get a 1 on top. On bottom, it's not so bad. It's 1 minus, that's 2/3 to the n. And this is going to be 3 times 3 over 2 to the n. Now, granted, there's something about this over here. All right, they're reciprocals one another. But anyway, I'm not saying it's clear right now what to do. Then when you get over here, you just get minus 2. All right? I'm still looking at this, and I'm wondering what to do, but it is a little bit simpler to look at now, although there are fractions there. I'm going to multiply it out. All right, now I multiply this out. Again, I'm hoping you see something when I multiply it out. What do you get? 1. You're going to get 3, and then you get 3 over 2 to the n. I'm multiplying by 1, by the way. Minus 2. Then you're going to get minus 2/3 to the n times 3 over 2 to the n. Then you get minus, no, not minus, it's plus, right? Plus 2 times 2/3 to the n. And I'm still going to try to massage this a little tiny bit. Still getting 1. I get 3 over here. I get 3 over 2 to the n. This guy over here, I'm going to try to pull it together, just like I normally would do. And what do you get there? You get minus 2. And these two terms over here come together pretty nicely, by the way. And what do I really get? I get minus 3. And then if you combine these two together over here, you're just going to get 1 to the n. Because 2 over 3 times 3 over 2 is 1, and they're both at the same power n. Not so bad. Then you get 2/3 to the n. Let me keep moving. I'm seeing 1. And then what do you see now? Let's take a look at this. You get 3 over 2 to the n minus, that's going to be 5 now, because 1 to the n is just simply 1 for some finite n, by the way. N's are integers, by the way. Plus 2/3 to the n. All right, now this is where I'm going to make a substitution. And the reason I want to get this thing to look like a polynomial so I can use partial fraction decomposition. All right, and someone says, why do you want to do that? I'm hoping it's telescoping. All right, let's write this down now. And what I'm going to do over here is I'm going to write down 1, but I'm going to make a substitution. And what I'm going to do is I'm going to say x equals. I'm going to say it equals 3 over 2 to the n. So that means 1 over x would be, it's reciprocal, right? 2/3 to the n. And I'm going to make a substitution now. So what do you get? I put a little star over here indicating that I'm making a substitution. It's going to be 3x minus 5 plus 2. And 2/3 to the n would just be 1 over x. I'll put this over here. The next thing I'm going to do is multiply top and bottom by x, get rid of the complex fraction. And I'm going to say I get something. I get x. Then I get 3x squared minus 5x plus 2. And this is where I'm starting to think that maybe it is going to be partial fractions, because I see the polynomial over polynomial. I'll write this one down for you. And I'm hoping it factors nicely. Let's see what we get there. And I'm going to say it looks like 1 and 2. And it looks like minus. I'm still going to check it. You get 3x squared. Minus 3x minus 2x minus 5x, you do get plus 2. So I'm going to make an assumption. I can do that. I'm going to say a over 3x minus 2 plus b over x minus 1. I'm going to clear the fraction. And I want to point out, clearing the fraction is over here. And someone says, what are you clearing? Let me just make sure you understand what I'm doing over here. I'm going to multiply both sides by the LCD. And what do you get? On the left side, that's the left side now, would be x. And on the right side, you get a times x minus 1 plus b times 3x minus 2. Now, depending on how you study partial fractions, you might have a different technique, but bottom line, we're not going to get different a's and b's. I'm going to select an easy number, like x equals 1. What would you get? Left side would be 1. What's the right side going to be? Well, the a would disappear because x, if x is 1, 1 minus 1 is 0. 0 times a is 0. Then you get b. And then you get 3 minus 2. which is 1. So this tells me b equals 1. You can pick another easy number. You could pick a fraction if you want, but I'm going to pick 0 because it's easier for me to do that. And what do you get? You get 0. And if I chose that, I know what the b is, but I don't know a yet. And if it's 0, I get minus a. And then you get plus 1. That's what b is. And then I get minus 2 over here. And I always say, be careful. Minus a, minus 2. You would get 2 equals minus a. Or you would get a equals minus 2. So I think I know what this is now. And what do you get over here? Well, let's see. B was 1. So I'm going to write it as 1 over x minus 1. And the b was minus 2. I'm sorry. The a was minus 2. Sorry about that. All right, that's a good place to start thinking about why we did that. And I'm going to write this down now. And I got to go back and make sure you understand where this thing came from. And what we did, we made a substitution. All right, and let's put that down now. All right, I said x was 3 over 2 to the n. So let's put that down now. All right, so this over here, I'm going to go back and get rid of that substitution, by the way. And I have to make sure I'm doing that right, by the way. It's going to be 1 over, and it's going to be x minus 1, and x was 3 over 2 to the n minus 1. That's x minus 1. Okay, let me go back and tell you what I'm doing. I'm taking this, which is what the x is, and plugging it in. And that's 3 over 2 to the n. All right, let's keep going. Minus is a 2. And it's going to be 3 times 3 over 2 to the n. That's what the x is, right? Minus 2. And this is a partial fraction decomposition. I'm going to continue to simplify a tiny little bit, by the way. And that's going to be 1 over 3 over 2 to the n minus 1. And what I'm going to do over here, I'm going to, because I want to get them look sort of similar, I'm going to multiply the top by half and the bottom by half. And let's put that down. The top would be 1, and the bottom would be 3 over 2 to the n minus 1. And things are starting to look up at this point. So I get 1 over 3 over 2 to the n minus 1 minus 1 over, what's this going to be? 3 over 2 to the n plus 1 minus 1. All right? That's a good place to put the summation down now. So let's write this down. I just figured out a partial fraction decomposition, and I'll write down what I mean by that. We just decompose this thing into 2 terms. Now, I realize some people say, I think I could have done that in a better way, and we're not saying you couldn't. I'm just saying that's the way that you could have done it. I'm going to post a video of another guy doing this too, and you might look at that and say that's a better way of doing it too. It's up to you. They're really kind of equivalent. So what do I get over here? 1. We get 3 over 2n minus 1 minus, put this in parentheses by the way, 1, 3 over 2, n plus 1 minus 1. All right, what I'm going to do now is I'm going to do a partial sum. I'm going to do s sub big N, and that's going to be the sum as n equals 1 up to big N of that partial fraction decomposition. And let's write it down. First term, 1 over, you get 3 over 2 minus 1. Next term, minus 1 over 3 over 2 squared minus 1. Plus the next term, 1 over, well, I'm at 2 now, so it's going to be 3 over 2 squared minus 1 minus 1 over 3 over 2 cubed minus 1. Now I start to realize that this is telescoping, and you kind of go to the end of it, and what's the end going to be? Well, when I get n, I'm going to hit that eventually. I'll get 1, and then you get 3 over 2 big N minus 1, and then you get 1, 3 over 2 big N plus 1 minus 1. Now, what I mean by telescoping, it's like a telescope. It kind of collapses. So looking at it, I'll tell you what the collapse is going to be now. This term here and that term there would disappear. All right? It's a finite sum, by the way. This term there'd be another one over here that would disappear there. And then, going, backwards on it, I'm going to say there'd be one over there to disappear. And then the question is, what would you be left off with? Well, you're left off with what's called a partial sum. And I'll write that down for you. Let me go back to black ink. You're left off with 1 over 3 over 2 minus 1 minus 1 over 3 over 2 to the big N plus 1 minus 1. And that's called the nth partial sum of the problem. All right? So now what I'm looking at over here is I need to get the infinite sum. So the infinite sum, and this is going to be n equals 1 to infinity, 6n, and I got to go back and read that again. Although it's kind of memorable at this point. This can equal the limit, by the way, this is Sn, as big N goes to infinity of Sn. And maybe I shouldn't have done that so quickly. I'll erase this over here. I'll write Sn down. And that's big N. All right, let's go back and do that limit now. Limit as the big N goes to infinity. I'm going to write it down now. It's 1 over 3 over 2 minus 1 minus 1 over 3 over 2 big N plus 1 minus 1. This is an easy limit to do. Number one reason why is this sum over here. This term over here. When N goes towards infinity, this goes towards infinity, and infinity minus 1 goes to infinity, and 1 divided by infinity goes to 0. So I'm left with some really kind of simple arithmetic over here. This is going to be 1 over 3 over 2 minus 1. I can multiply top and bottom by 2. And what do you get there? You get 2. On bottom, what do you get? 3, because 3 times 3 has is 3. And 3 times 1 is 2. And you get 2 over 3 minus 2, which is 1. And the sum turns out to be 2. Again, if you went back to the original student's work, by the way, they did make a mistake, and they concluded it was 1, by the way. The sum is 2. And I'll show, I'm also going to show Sage on this one over here. And I think I might even show Wolfram Alpha. You can't hurt to look at software tools, by the way. And you want to be able to do that too. All right, but I think that concludes it. And I'll put some Sage code down there and also the Wolfram Alpha code when I get a chance. And plus, you'll see the typed up solutions over here. A little bit neater than my chicken scratch at the board. Thank you.